All right, guys, so I'm here to talk you through some instructions on what to do with the PhET Balancing Act simulation. So if you click on the first link, it's the lab sheet that you're trying to fill in. So you're just following the directions. I'll show you where to go and how to find it. But you're just trying to complete these tasks and doing some calculations of torque and trying to get the net torque to be zero. And then down here at the bottom, you're trying to calculate or determine the mass of these different mystery boxes. And you do that with your setup in the lab. So let me take you to the lab. So if you go back to the simulation lab and you click where it says link here, PhET Balancing Act link, you go to balancing, that's where you start. So you want to take off the supports from underneath. I would say you want to show the forces and you want to show the level. Rulers are usually helpful to help you know how far you are. So the balancing point, or the point that it's balanced at currently, this is the zero, and you're going to measure to the right and to the left how far you need to go for different things. So let me just set up kind of a basic one. So in the first one, it says you're trying to put the 20 kilogram child on 5 mark, and then you're trying to take the 80 kilogram man and make it balanced. So coming back to this, you want to grab people, so you click to the right here, and we got a 20 kilogram at 1.75, and we got a person, and we're trying to make them balance. So that's too far, that's not far enough. So you try to make it work, but you quickly run into some trouble and decide that you can't get it to work. But that means that your answer for the place where this 80 kilogram person should be positioned is between those 2 points. So you're going to calculate that and keep going with that part here. So could you get the situation balanced? The answer here is no. And then how could it still help you support your prediction? Like, yeah, it's going to tell you kind of where to go. And then you predict some other things. So you put these different bricks at different places and figure out where you can put it to balance, and then evaluate your calculations using the simulation. So you can do the simulation first and get it to balance, and then plug in and get the do the math. But it's up to you how you want to do it, but show your work. And then over here on these, you have to experimentally set up some way to get it to balance in the simulation. So I'm going to reset everything. I'm going to take the supports off and go to forces again and rulers. And then you keep scrolling to the right, and eventually you get to these boxes. So you're trying to figure out, okay, I'm going to put A over here, and then, I don't know, put that there, and try to get the balance. And actually, I guessed right. That was the right one. So A is 20 kilograms, and I would do like 20 times the mass, which is 9.8, times this distance, which is 1, is equal to A, the mass of A, times 9.8 times the distance, which is 1. So that means that these are equal in mass. So they're both 20. So you do similar kind of setups and trying different, setups. So like if I tried, I don't know, B, and I put B over here at 1. Okay, it's not balanced. I can move, so that means like B is this is probably too heavy, so I can move this in maybe. It's still too heavy, maybe, I don't know. So anyway, you're gonna try those out. So I'm gonna stop there with the directions, but it's pretty straightforward. You're just making stuff balance. If you were in class, then you don't have to worry about kind of watching these instructions because I showed it to you in class. But this for those people that weren't in class today. So I'm gonna go ahead and stop there.